Hello candidates, welcome to another science session, and today we shall be looking at mechanical advantage, which we can abbreviate as MA in capital letters. So this stands for mechanical advantage. In case you're told to write it in full, you can write it as mechanical advantage. So mechanical advantage is the number of times a machine simplifies work. This one actually appears to have two definitions. One of them is that it is the number of times a machine simplifies work. So you realize that different machines simplify work in different ways. So this is exactly what we are talking about, the mechanical advantage. The number of times a machine simplifies work. Or we can have it as the ratio of load to effort, which can be expressed as a fraction in that way. So one thing you need to know about mechanical advantage is that it has no units. Because it is a ratio, so it has no units. And then friction also lowers the mechanical advantage. Just like we saw that friction affects the efficiency of a machine, it also lowers the mechanical advantage. So if we can do some calculations about the mechanical advantage, here we have one of our examples. The first one, find the mechanical advantage of a lever using 5 newtons, that is the effort, to carry a load of 50 newtons. So we shall say mechanical advantage is equal to load out of effort. And this one will give us, our load is 50 newtons. So we shall have 50 newtons out of our effort, which is 5 newtons. Now, since we have newtons here and here, these ones will cross out. This is one main reason why mechanical advantage does not have any units. So we shall divide by 5 here, that is 1, and by 5, this is 10. So we shall have our mechanical advantage, which will be equal to 10. There is nothing that we put here as the units because we've already crossed them out. So that means our final answer here is 10. Now, this question is set in form of statement, so what we may call word problems. You just have to interpret what they are saying here, and then you come up with the answer. But then, in other times, you will have to interpret a diagram like this one. They are saying, find the mechanical advantage of the seesaw below. So here, we shall identify where the load is and where the effort is. Remember, in the beginning we said that the load is always nearer to the pivot than the effort. And of course, it makes sense that the load is heavier. So we shall say mechanical advantage is equal to load out of effort. And our load is 80 kilograms. Our effort is 40 kilograms. So we shall cross out the units first, and then we shall cross out the zeros. Then we can divide by 4, this is 1, and then by 4 here, that is 2. Then we shall say mechanical advantage is equal to 2. And then we underline our answer like that. Now, in all other machines, this is how we work out the mechanical advantage. But then it becomes very different when we come to inclined planes. We shall find that the way we find the mechanical advantage is quite different. For example, here you can see that the mechanical advantage of an inclined plane is the ratio of the effort distance to the load distance. In other words, we shall say, for example, given this question, find the mechanical advantage of the inclined plane below. We shall say mechanical advantage is equal to, back to this statement, we've said effort distance out of the load distance. Now this is where you need to pay to be very careful with this example, because you need to identify where the effort distance is and where the load distance is. In our previous session, we said this distance is the effort distance and this is the load distance. So we shall have 8 meters as our effort distance, and then our load distance will be 4 meters. Now, some people may choose to write another step or cancel from there. That will be just fine. We shall have 8 meters. Out of 4 meters, units will first cross out, and then by 4 this is 1, by 4 this is 2. So we shall end up having our mechanical advantage, which will be equal to 2 with no units. Thank you very much for being part of this session. The activity for this work will be attached to this video. Please do it carefully.